Hello, Dr. M. Jha this side. Once again, I have come to discuss one of the chapter of Project Planning and Evaluation, BBA 302. Today's topic is further part of the network diagram, and we will try to find out the probability of completing the project within given time period. We have been given some data related to network diagram consisting 6 activities are given in the blue colored table below. What are those data? 6 activities 1, 2, 1, 3, 2, 4, 3, 4, 2, 5, 4, 5, and in front of these activities 3 time values have been assigned: optimistic time, most likely time, and pessimistic time, TO, TM, and TP. On the basis of above, some questions have been asked. First, what is the critical path of the network diagram? Constructed on the basis of data in the table. Second, what is the standard deviation delta of the critical path duration? Third, and the most important, which is the heading of this slide, that is, what is the probability of completing the project in a specified time? Here time is 20 weeks. What is the probability to complete the project in 20 weeks? So we will try to find out the question of all these three. Solution. For convenience, average time or expected time TE for each activity is calculated extending the blue colored table right and coloring it red by using formula TE equal to TO plus TM plus TP by 6. Means this the input given in the blue colored that we extended rightward and colored red, and there itself we are calculating average time or time expected, that is TE, which is T0 plus 4TM plus TP by 6. This formula we know, and the way it is calculated, that also we know from previous part of the same subject we discussed few days back. So time expected we calculated out are 3, 6, 5, 9, 4, 8 for activities 1, 2, 1, 3, 2, 4, 3, 4, 2, 5, 4, 5 respectively. So once we calculated the time expected or average time, on that ground we can now construct a network diagram. We know how to construct. We had done earlier. We constructed many times network diagram. So accordingly here also we can construct the network diagram by using time expected and the activities given in the blue colored table. So this will be the network diagram. Now in this network diagram there are 3 paths starting from the originating event 1 to terminating event 5. These 3 paths are 1, 3, 4, 5, 1, 2, 4, 5, and 1, 2, 5. Total duration of 1, 3, 4, 5 is 23. Total duration of 1, 2, 4, 5 is 16. And total duration of 1, 2, 5 is 7. Now we will start answering all the 3 questions which we have been asked. A. Answer of question 1, critical path. Critical path, as per definition, is the longest path in the network diagram. And what is the longest path? That is 23 unit, time unit. And this 23 time unit is of path 1345. So 1345 is the longest path, is the critical path of the diagram constructed above. And all three activities falling on this critical path 1345, 1334 and 45 are indicated by double arrow. Just look at this diagram 1334 and 46 double arrowed. So first we answered, now we'll answer question 2. Standard deviation delta of the critical path duration 1345. It is calculated as below. Activity 1, 3, 3, 4, 4, 5, all the critical activities, and in front of we are given TP and TO, and delta is calculated. Delta is equal to TP minus TO divided by 6 for 1, 3, 3, 4, and 4, 5. Delta, I mean standard deviation, will be 1, 1.33, and 1. Accordingly, in front of all these three critical activities, we can calculate variance. Variance is equal to delta square, SD square, and that will be 1, 1.77, and 1, respectively for critical activities 1, 3, 3, 4, 4, 5. Now, summation of all these variance of the critical path duration is 3.77. When we know the variance of the critical path duration, we can easily calculate the standard deviation of critical path duration. That will be the square root of the sum of the variances of activity duration on the critical path. And the answer will be 1.94. So this is the answer of the question 2. Standard deviation delta of the critical path duration is 1.94. Now answer of question 3. This is the topic question. What is the probability of completing the project in a given period within given time? Here time is 20 weeks. What is the probability of completing the project in 20 weeks? And before that we calculated two things. One, critical path duration. Second, standard deviation. Now for answering question 3, to find out the probability, we will apply a formula, Z formula. Z is equal to D minus T whole divided by delta. Now it is interesting to understand what is D, what is T. D is 20, means D is a specific time given in the question for which we need to find out the probability whether the project can be completed, and if, then what is the probability thereof. So D is equal to 20, it is given in question. T is the mean value of the critical path, means critical path duration, which is calculated as 23. So T is 23, and delta we know 1.94, standard deviation, which is calculated as above. Now we need to understand what is Z. It represents the number of standard deviation by which D means specific time, what is given in question, exceeds T means mean value of critical path, means how many times, how many multiple of standard deviation D exceeds T, means given time period exceeds the mean value of critical path. How many multiple of standard deviation. Meaning how many times in the multiple of standard deviation. This is Z. And why we calculate Z? Determining Z is equivalent to converting our specific normal distribution with mean T and SD delta into a standard distribution, a standard normal distribution, of which mean and SD are 0 and 1. For a standard normal distribution, mean is 0 and SD is 1 plus 1 minus, and in the multiple of 1, both sides left and right, as it is depicted in this graph. Z score 0. This is mean. This is a standard mean. When the SD is 1, 1 plus 1 minus, again 1 adding both sides, so 2 plus 2 minus and 3 plus 3 minus. So this is the conversion of distribution table in the standard normal distribution. So we calculate Z. Now, once we could know the importance of Z and what is Z, what is D, what is T, we calculate Z in this table. A specific state dt, mean value, that is critical path value T 23, Z will be equal to 20 minus 23 whole divided by 1.94 is equal to minus 1.55. Means probability of completion by D is equal to 0.055. Now, what is 0.055? Because we have yet not calculated 0.055, where it comes from. We have calculated Z, and we are now correlating Z, means 1.55 to 0.055. This is taken from the Z table, the corresponding value from the Z table. The nearest value of 1.55 minus is taken over here, is taken from this table. What is the nearest? In minus 1.55, nearest is minus 1.6, and corresponding value is 0.055. So 0.055 will be the answer. 0.055 is probability, means probability of completing the project in 20 weeks is 5.5% or 0.055. So there is very less probability, but yes, there is probability. Thank you. Thank you very much.